Okay, so we are going to discuss what the differences are between duty cycle, pulse width, and frequency. And then we are going to use our Picoscope software to measure those three different things. So we're going to start with pulse width. Pulse width is how long something is on, or the amount of time something is commanded. Okay, so for our example, we are looking at a waveform of a fuel injector voltage. And as we know, computers are commanding fuel injectors on for a specific amount of time to control how much fuel is being sprayed into the engine. So if we wanted to measure how long the computer is commanding this fuel injector, we could drag over our cursors, one to this point right here where it's being turned on, and the other one to this point right here where it's being turned off. And then we use this reading at the top of our screen. This is our delta reading, or the difference between this cursor and this cursor. And now we know that the computer pulsed this fuel injector on for 1.112 milliseconds. Now we're going to discuss the term duty cycle. Duty cycle is a measurement of on time versus off time, and it is measured in percent. Okay, so it's not time like pulse width was, it's percent. And you're often going to see duty cycle interchangeable with the term pulse width modulation. So pulse width modulation is when the computer is changing this on versus off time in order to control the amount of current going to a specific component. And by controlling the amount of current, we can control things like fuel pressure in a fuel pump, or how far a solenoid opens, or the dimness of a bulb, those kinds of things. Okay, so this is actually a waveform of a solenoid being duty cycled or pulse width modulated. So if I wanted to measure what that duty cycle was, what we would do is pull over our blue rulers from over here, and we would go to our first rising edge, and then we would take our other ruler over to our next rising edge. Now these rulers automatically default to 2 cycles, or 200%. But if we double click this, we can change that to 100 because we do percentages in the 100% range. Okay, and now that we've done that, we can pull out our white cursor, and what it will do is it will measure how much percentage from our first blue ruler. And it will show up top right here. So this is a 62.47% duty cycle. Now something you need to be careful with measuring duty cycle is you need to know, is the computer pulsing the negative with the ground wire, or is it pulsing the positive wire? Because if it's pulsing the ground wire, the on time is actually this down here. If it's pulsing the power wire, then it's this one up here. So you need to know how this thing is being controlled, or else your duty cycle is going to be backwards from what it should be. Okay, but that is how you measure it, and that is what it is. So quick recap, pulse width is amount of time, duty cycle is percentage of on versus off time. Now we're going to discuss our last term, which is frequency. Frequency is the amount of times something happens per second. Okay, a great example of frequency would be like a GM mass airflow sensor, or even a crankshaft position sensor. Frequency can be converted into RPM. So the engine looks at the crankshaft position sensor, counts how many times it sees those teeth pass by, and uses it to calculate the RPM. Right, so we can measure that on this, even though this isn't a crankshaft position sensor. We could still take a measurement, and the first and most accurate way to do that would be to add a measurement down here, and we would do it on channel A, and we'd say frequency, and we're going to do it between rulers. And so now we're going to drag these rulers out, and we're going to go from our first rising edge over to our second rising edge, and you'll see that it calculates our frequency down here, 300.8 hertz. But it also does it automatically when I drag out these cursors over here on the right, and it tells us that our frequency is 300.9 hertz. And it uses that to calculate our RPM, which is 18,055. Okay, so again, this isn't a crankshaft position sensor, but that is how you measure frequency. So a quick little recap on all three. Remember, pulse width is the amount of time something is on or how long it's being commanded. Duty cycle is percentage of on time versus off time. And frequency is how many times something happens per second.